Today I would like to tell you about my friend, your friend, and everybody's friend, oxygen. Oxygen is so important to life on Earth. You see, an oxygen atom is warm-hearted, always out making friends. This property of oxygen is called reactivity. Reactivity can be critical for life, but can also make oxygen dangerous. It depends on where oxygen is and whom it is with. When two oxygen atoms combine, we call them an oxygen molecule, or O2. O2 is a gas that makes up 1/5 of the world's atmosphere. But oxygen molecules also make friends with lots of other atoms. Atoms join together to form molecules. But when atoms leave their partner atoms to join oxygen, new molecules are formed. This process is called oxidation. One oxidation reaction that is essential for human life is respiration. Every time you breathe, oxygen enters your bloodstream through your lungs. From there, it travels to cells in your body, and when you eat, molecules from the food are oxidized and release carbon dioxide, or CO2. These processes give you energy and keep your body warm. Oxidation also occurs when wood, mostly carbon, is burned. CO2 is also released, and this reaction produces a tremendous amount of energy. A piece of iron left out in the rain combines with oxygen to make rust, or iron oxide. This is also the oxidation process. Another kind of oxygen reaction happens when automobiles and factories release pollutants into the air. When it's hot and sunny, pollutants provide the right conditions for an oxygen atom to combine with an oxygen molecule to produce ozone, a molecule that has 3 atoms of oxygen. If you think oxygen is reactive, you ought to meet ozone. Ozone is helpful up in the stratosphere, about 6 miles or 10 kilometers straight up. He is not welcome down here in the troposphere because ozone is much more reactive than oxygen. It can even react with your lungs. This can damage them, leading to asthma and infections, especially for kids and older people. When plants get exposed to ozone, oxidation can cause them to lose the ability to carry on photosynthesis, a process plants use to make food and grow. When ozone is in the stratosphere, it traps the most harmful of the ultraviolet, or UV rays, like a giant sun shield. Without ozone, life could only exist in the oceans, as it did a few billion years ago. Be careful, because as good a goalie as ozone is, some UV rays do get through. UV rays don't just cause sunburn, but can also cause cancer and cataracts. When stratospheric ozone absorbs UV rays, it sometimes lets go of an oxygen atom and becomes oxygen and a spare oxygen atom. When that oxygen atom meets another oxygen, it combines with it to become ozone again. For millions and millions of years, all that back and forth was in balance. But in the 60s, 70s, and 80s, ozone fell victim to CFCs, or chlorofluorocarbons. CFCs are chemicals used in making aerosol sprays and refrigerants. Everyone thought CFCs were cool. No pun intended. CFCs aren't a problem until they reach the stratosphere. Up there, they release chlorine, which disrupts that nice old balance between oxygen and ozone. Chlorine is a catalyst. It makes ozone break down into oxygen faster than ozone can form again, leaving less ozone than there should be. These pushy chlorines continue to hang around, breaking up more and more ozone. This caused a small decline in our global ozone shield, creating a hole over the Antarctic in the winter and spring, exposing life on Earth to more UV rays. Scientists recognized the problem. The government listened and took action. Although CFCs are banned, the hole in our ozone layer could take a long time to mend. So, thanks to oxygen's friendly property called reactivity, we have life here on Earth. We just have to take care of our atmosphere.